Okay, so I'm going to skip several items on these notes just because they're way too basic for what you need. So we'll just discuss a few of them. So let's do a little bit of review. So this is a good review because you haven't had it for a while. You have a test coming up next week. This is the last section of the chapter. So I want you to cross out the shapes that are not polygons. So keep a shape if it is a polygon. So cross it out if it's not a polygon. So what's the definition of a polygon? Somebody want to give me, there's two parts to it. Because you should have been learning your definition. So what's part one? It's a closed figure. So that's part one. Does any one of these not match that requirement? This one right here and E. Okay, so those are not polygons because they're not closed. All right, what's the second part? It does have to have at least three sides. What's the other part? This is not a polygon. Why? Because what? Well, it has sides. It's just curved sides, right? You need to have straight edges. So the basic definition of a polygon is that it is a closed figure with straight edges and at least three sides. Because if you don't have three sides, you're not going to be able to close that figure, as this one here is demonstrating. So this is a polygon. This one actually is not. Why? It's got these lines in it. It's kind of a weird one because without the lines in the middle, you'd say it's a polygon. And typically, they'll show this one without those edges there. That's not a polygon either, even though it's closed and it's got straight edges, but none of the sides can touch each other. So, you know, this one I could argue with you on this one being a polygon only because of my knowledge of geometry, but I think that's an unfair one. But anyway, so you could go either way on that one. This one, definitely a polygon. I'm not going to throw one like that to you on a test. So then when I was looking at this one originally, I'm like, write the name of each figure. They got the name of the figure above the figure. Is that a triangle? Yeah, that's a triangle. I'm pretty sure we can all name these figures, don't you think? We don't need to really do this one. What is the third one? No, it's not a rectangle. I know. All right, so then look at your vocabulary word that you need to add. So consecutive. You should have had consecutive integer problems last year. Do you remember those? What would be a consecutive integer? What would be an example of that? 2, 4, 6 would be consecutive even integers. What would be consecutive integers? 1, 2, 3, 4. Consecutive letters. There you go. So we don't need to do questions. We don't need to do questions 3 through 5, do we? All right. So, and they do give you an example of consecutive even here. So know the difference between plain consecutive and consecutive even. This you do need to know. Now, if you don't already know this from middle school and your freshman year, you've got 4 different formulas, actually more like 8, because you've got formulas for perimeter and area of each of these 4 basic figures. I expect that you know those formulas without them being given to you, because you've had them over and over again. Now, the hardest one for you is going to be circumference and area of a circle. Those are the formulas that get messed up all the time. And the easiest way for you to remember, bless you, and again, the easiest way for you to remember which formula goes with circumference and which formula goes with area on a circle, think of it this way. Which is squared, perimeter or area? Which has squared units? All right, let's talk about dimensions of various things. If I asked you to look at the perimeter of this room, can you see the perimeter of this room? The first dimension is sight. So I can see the perimeter of this room. The minute I go to touch the perimeter of this room, what am I actually touching? The floor and the wall. I can't actually touch perimeter. Touch is the second dimension. So since I can see perimeter of something, but I can't actually touch it, perimeter is one-dimensional. That's why perimeter always has things to the first power. In other words, if I were to measure the perimeter of this room, it would be in feet, not feet squared. Agreed? Because with perimeter, we're just adding up all the sides. So on a square, if the sides are all s, I like to call the side of a square s instead of x. So if I did s plus s, that's 2s, plus s, 3s, plus s is 4s. So if I assign feet to this, let's say I had 10 feet. 10 feet plus 10 feet is 20 feet, not 20 feet squared, correct? How does the squaring come into play? How do I end up getting squared feet? Not through addition, through what? Multiplication. So area is actually two-dimensional. Like, let's look at the floor of this room. I can see the floor of the room, right? Can you touch the floor of the room? Yes. Can you pick up the floor? No, the minute you pick up the floor, it now has volume, right? You actually can't pick up just the area of the floor. When you pick it up, it then becomes, it has a depth to it. And so that's now becomes a solid. So you have to look at like the thin veneer of your desk. You can see your desk, you can touch your desk, but you actually can't pick up the area of the top of that desk. The minute you do, you're picking up volume of your desk. So volume is three-dimensional because it has three dimensions: sight, touch, and feel. Well, I don't know, feel. How do I describe that? It's just got depth to it, right? So here with a circle, you've got pi d or 2 pi r. Both of these have nothing squared in it, do they? But this is pi r squared. Area is always squared units. That's for area, right? But you've got two different formulas for circumference. So to keep them straight, when you're trying to figure out which is which, think, okay, I'm finding area. Area is squared because I can see it and touch it. So pi r squared belongs to area. So if you don't know these, put them on flashcards. Now this may seem silly to you, but oftentimes I will write out the words. A triangle has a base of 10 feet and a height of 8 feet. Find the area of the triangle, and I don't give you a picture on purpose because there are some people that don't know what a triangle looks like. And they give me like the area of something else. Especially when we start to get to trapezoids and things like that. And then I get a picture of a triangle because of a trapezoid. So make sure that you understand what it looks like also. So some of you that may seem basic, but others of you are like, oh yeah, I never really thought about that. All right, so, and although you have all these separate perimeter formulas, except for circle, do you really need to memorize the perimeter formula for any polygon? What does perimeter mean for any polygon? Just add up all the sides. So yes, we can create a perimeter formula for a triangle and for a rectangle and so forth. Guys? Thank you. But I would not memorize those. So the area formulas are the only ones that you really need to know. And quite honestly, most area formulas, except for the circle, comes from the area of a rectangle. So the square is s squared only because the base and the height are the same. The triangle, isn't that half of a square or a rectangle? And so it's 1/2 base times height because it's just half of it. So most area formulas, as we get into quadrilaterals, they are derived from that formula for a rectangle. So you really want to memorize something if you know how it's derived. I'm not big on memorization. All right, so look at problem 1. You want to frame a picture that is 5 inches by 7 inches with a 1-inch wide frame. So here's what your frame looks like. There's me with green hair in the picture. All right, so the picture is 5 by 7. So this right here is 5, and this right here is 7 inches. But the frame itself, all the way around here, is 1 inch. So what is the length here, if from here to here is 7 inches? So I've got 1 inch here, plus 7, plus 1 more inch. So this is 9 inches. And what's this width here? 7, because you've got 1 plus 5 plus 1. So this is 7 inches. So the outside of the frame is 9 inches by 7 inches. It says, what is the perimeter of the picture? So perimeter of the picture, you find that. And if this were a multiple choice question, one of the answered choices would be 12 inches. Why? Because usually they're only going to label the length and the width. They're not going to label all 4 sides. And oftentimes students only add what's labeled. But there's more than just 5 and 7. We've got another 5 and another 7. So 5 plus 5 plus 7 plus 7 is what? 24. So the picture is 5 inches by 7 inches. And who really cares about the formula for the picture? But there it is, right? Because you could create it yourself. And then you've got, and I don't even care if you use this formula. You could just say perimeter is 5 inches plus 5 inches plus 7 inches plus 7 inches. I really don't care for perimeter. And so that's how you end up with your 24 inches. They wanted you to use substitution, sub in for your base and your height, which is fine. You can do that too. No, they didn't ask you that. So I'm going to add to this after we're done here in a minute. This one they want you to add by 24 inches. So we're going to find the area of the frame. Is the area of the frame a normal shape? This shape right here, this is a normal shape. That's not a square, it's not a rectangle. It's a frame, right? But if I want to get the area of that frame, think of this as a cake. And some rude person goes in, they don't like frosting. I don't know why, but they don't like frosting. And so they went and they took out the piece in the middle of the cake and just took out the middle piece. How many of you like the middle brownie in the pan? Me. Brownies are typically, well, in my household, if you have a little brownie in a 9x9 brownie pan, it's cut into a 3x3. That leaves one brownie in the middle. My daughter and I always fight for the middle brownie. So if I cut it and I don't eat it originally, then I'll go in there and she literally has taken out the middle brownie out of the pan. Like, really? Are you kidding me? Well, you didn't take it, Mom. So this would be my daughter taking out the middle brownie. So if you have the area of the whole outside, so the area of the big, if I can spell correctly, area of the big minus area of the small. So the small in our purpose is the picture. So both shapes happen to be rectangles, and so you're going to take base times height and subtract base times height to get the area of the frame. So you figure out what that is. Use substitution. Area of the big. Take out the area of the small. That'll leave you the frame left over. Share with somebody around you. What'd you get? Okay. So let me show you one little thing. You are correct. It is 28 inches squared. One thing that Common Core is big into, and again, I don't know what test you're going to take. Legislation has not occurred. When you use substitution, they want you to substitute in the units of measure as part of your calculation. If they don't see that, they're going to mark off points. Just to let you know. And so make sure you put that in there. So circumference. On this particular problem, we had a radius of 24. So the radius 24. What's wrong with the picture? Radius of 24. What's wrong with the picture? That's right. And it's hard to tell with this picture because this is a student solution. The student made the 24 the diameter, right? So really, the picture should have looked like this. Oh, that's a really good picture. 24. So they should have used C equals. If they did pi d, which I wouldn't here, I would have used 2 pi r. They should have substituted in for the r here, that 24. Don't back up. I can watch the clock just as much as you. And then here, find the perimeter of the coordinate plane. You're going to use the distance formula. Shh, I'll hold you after the bell. You're going to use the distance formula to find the side lengths, and then you're going to add those sides up. Area of a circle we already discussed was pi r squared. I don't think you need that. And then these shapes are weird shapes. You had those last year also. Cut them into pieces, find the area of each piece, and add them together. And that's it. Most of this should be a complete review of stuff that you've done in the past. So your assignment's up there on the board. I will answer questions on Tuesday. Please turn in